What good is half a wing? Have you ever noticed how many feathered dinosaurs run around with just half wings on their forearms, like Caudipteryx about 125 million years ago? And for the longest time, we were told the story that these, what we call pennaceous feathers, so these are some of the first modern feathers, like we find in modern birds, that these pennaceous feathers aided this animal in maybe leaping higher up off the ground, right? By flapping those feathers, this animal, Caudipteryx, could get a little higher up off the ground, maybe catch a dragonfly that much higher up in the air, or escape from a terrestrial predator. Running, and a little flap, and you're high enough up in the tree that you've escaped the predator. But some new research suggests a totally novel model for the evolution of these pennaceous feathers on the forearm and on the tail of dinosaurs. Check it out. So to test the hypothesis that these pennaceous feathers may have evolved, at least in part, on the forearms and tails of dinosaurs to startle prey, researchers built a robotic dinosaur, and they could manipulate the forearm feathers and the tail feathers, and then they literally subjected grasshoppers to startle experiments using the dinosaur. Check this out. So in a series of tests, researchers had their robot, which again was based on Caudipteryx here in the bottom panel, stalk grasshoppers. And they could manipulate whether or not the robot was wearing its feathers on its forearm and its tail or not. And so what they would do is, as the robot approached the grasshopper, they would periodically stop the robot and go through a series of movements and motions, essentially kind of extending its arms and opening them, very much like modern birds will sometimes use their feathers to open and startle prey, literally out of hiding. So this is a hypothesis that has modern support for the function of feathers. In addition, obviously, modern feathers have all sorts of functions, but startling prey is one of them. We see this commonly in animals like roadrunner that will use their tails and their wings to literally startle grasshoppers out of the brush. And so what the researchers did was, at different distances from the target grasshopper, they had their robot go through these motions and evaluated whether or not the grasshopper startled. Every time a grasshopper gets startled, it becomes much more vulnerable, right? Because a grasshopper is fairly camouflaged as long as it's sitting still on something, on a background that it kind of resembles. But as soon as it jumps, it is vulnerable. It's made itself known to the potential predator. So let's talk about what they found. And what they found was strong support for the hypothesis that feathers aid in startling prey out of hiding. Because when their robot was wearing its feathers, grasshoppers startled at a further distance from the robot and more often, right? So over 90% of the grasshoppers in experiments with a feathered robot startled when the robot moved its feathers out and up. Whereas only about 50% of the grasshoppers startled to the robot not wearing its feathers. So what I find so fun and compelling about this research is, one, they built a robot, and anytime you're using robots in evolutionary biology or animal behavior, it's a win in my book. Second, it emphasizes the fact that the initial evolution of feathers had nothing to do with flight. And in fact, I and a lot smarter people than me are really starting to suggest and argue that those feathers, even on the arms, had nothing to do with lift in their initial evolution. And instead, this current research suggests they may have had a lot to do with catching prey, and folks like me who study sexual selection and mate choice and the evolution of elaborate displays have no doubt that one of the primary functions and the initial evolution of these larger pennaceous feathers on the forearms and tails was communication, probably in mate choice and sexual selection. So in my mind, all of the feathers on the forearms and the tails of our feathered dinosaurs were highly colorful, at least during the breeding season, and would have been used in communication in the context of mate choice. Awesome stuff. Flight came way after the sexual selection and courtship and potential prey startling functions of these feathers. How cool is that?